At equilibrium, if HI dissociates 50%, then Kc of the reaction is given here, that 1 mole of HI is getting decomposed to form half mole of H2O and half mole of I2. Then for this particular process, you have to just find out the Kc value. Let me write here the equation once again. We have HI in the gaseous state, equilibrium is there, half H2, half I2. Now in this case, equilibrium constant Kc can be found out using the equation molar concentration of H2 raised to the power 1 by 2, I2 raised to the power 1 by 2 as per the given equation. Chemical reaction we are following here, and here is HI. Now initially the concentration of HI is maximum. Now let's assume initially its concentration is 1. We are talking about the initial concentration. It was 1 and these two were 0. Now at equilibrium, as per the question, HI dissociates 50%. So this would be 50% dissociation, alpha by 2, and it would also be alpha by 2. So what would be the amount of this HI? This would be 1 minus alpha. Now let's solve this for the value of Kc. That would be equal to the concentration of H2, that is alpha by 2 raised to the power 1 by 2. Then for I2 it is alpha by 2 once again raised to the power 1 by 2. Then it is divided by the concentration of HI. What is that? That is 1 minus alpha. This would be the value. And if you solve this 1 by 2, on solving you will find out this value. And this value is given in option 2. So I'm just choosing it as my correct answer. Now after this, let's take question number 67. If Ksp of barium hydroxide is 5 into 10 raised to the power minus 7, then pH of its saturated solution will be. What we have here, barium hydroxide. Now it's getting changed into barium ions and hydroxide ions. 2 hydroxide ions would be formed here. So let's assume their solubilities are here. Now we know that Ksp value, that is the product of the solubilities. So this should be S2, that is equal to 5 into 10 raised to the power minus 7. It is given in the question. So this would be equal to 4S cube. That's equal to 5 into 10 raised to the power minus 7. Now, with the help of this, we can find out the value of solubility. That is basically equal to 5 into 10 raised to the power minus 7 divided by 4, and we just have to take its cube root. And on solving, you will identify that this value is 5 into 10 raised to the power minus 3. Now, we just want to know the value of OH minus ion. Why? Because we just want to find out the pOH value, with the help of which we will find out the pH value also. So this OH minus ion concentration is equal to 2S, and solubility we have, that is 5 into 10 raised to the power minus 3. So it would be 2 into 5 into 10 raised to the power minus 3. 5 2s are 10 here. So it would be 10 into 10 raised to the power minus 3 or 10 raised to the power minus 2. Concentration of OH minus ion you have. So what would be the value of pOH? It would be negative log of OH minus ion concentration. So that would be equal to 2. Now pH value, we know that pH is 14 minus pOH, because pH plus pOH is 14. So this pH is 14 minus 2, that's why 12. So where this 12 is given? In option 2 it's given, that's why the correct answer is option 2. Now after this, let's take next question. If delta H for the reaction X plus 2Y2 is giving you XY4 is 0, all the reactants and the products are in the gaseous state, then formation of product is favored at. We are just going to talk about the equilibrium condition, and one thing is given, that for this particular reaction, this is the reaction XY4, yeah. In this case, this delta H value is 0. It means there is no enthalpy change. It means there is no effect of temperature. This is temperature independent reaction. And in such type of reaction, there can be the role of pressure. Let's check the given reaction. If you look at this given reaction, there are 3 moles at the reactant side and the 1 mole at the product side. It means if you raise the pressure, then equilibrium will be shifted in that direction where the number of moles are less. And that is the favorable condition. So formation of the product would be favored by increasing pressure. So definitely option 3 is the correct option, that states high pressure, and you should also choose that. After that, question number 69. Equivalent mass of N2 in the given reaction is N2 combining with 3H2 giving you 2NH3. Haber's process it is. Ammonia gas is formed. You have to just find out the equilibrium mass for N2. Equivalent mass for N2 you're just going to calculate. We know that this equivalent mass depends on N factor. Equivalent mass is equal to the molar mass of the substance and just divide it by the N factor. What is the N factor for nitrogen? Now for the given reaction, this N2 is getting changed into NH3. Now we just have to balance the charge here. So in this case, you just have to add 6 electrons because 0 oxidation number is here and -3 is here. To balance this, you have to add 6 electrons. So N factor is 6 from this, and the equivalent mass that you just want to find out is equal to molar mass. Molar mass for the nitrogen is 14 into 2, 28 divided by 6, and this value is equal to 14/3. And yes, that is given in option 2. And this is my correct answer. Let's take question number 70. An acid solution of pH 10⁵ is diluted up to 1000 times. The pH of resulting solution becomes. We have an acid and its pH is given, that is 5. So what would be the H+ ion concentration for this particular case? That would be 10⁻⁻5. Now to find out the concentration of the final solution after dilution, we have to use the molarity equation that states M1V1 is M2V2. These two are equal. Initially the concentration of H+ ion is 10⁻⁻5. We already have taken. Volume, let's assume that was 1 liter only. Now molarity is changed and the volume becomes 1000 times of the initial one because the dilution is there. So this M2 value is equal to 10⁻⁻5 into 10⁻⁻3. So it is 10⁻⁻8. This is the concentration of the final solution, but this is not the case because you are just adding water also. In case of water, there are certain number of H+ ion also because you are just going to add acid, going to add water in acid. That's why there is a contribution of water also towards the acidity of the solution. So the total concentration of H+ ion in the solution is equal to the H+ ion from the acid plus H+ ion from the water also. Those are 10⁻⁻7. So this value is equal to 1.1 into 10⁻⁻7. This is the H+ ion concentration there. And what is pH? We all know this is negative log of H+ ion concentration. We have to take log of this and you will find out that this value is equal to 6.95, the pH value. And if it is the pH value, we can easily choose the correct answer that's given in option 3. I hope this question is clear to you. Let's take next question.